Welcome back to my channel LinkedIn Pharma. Today we have discussed about coal and petroleum, chapter 3 in class 8. Before starting this video, please like and subscribe to my channel LinkedIn Pharma. Let's start. Introduction to coal and petroleum. Coal and petroleum are two vital natural resources that have played significant roles in shaping the modern world. Both substances are fossil fuels formed over millions of years from the remains of ancient plants and organisms. They are crucial sources of energy, powering various industries and providing fuel for transportation. Coal, a black or brownish-black combustible rock, is the most abundant fossil fuel on Earth. It is extracted through mining and used primarily for electricity generation, as well as in the production of steel and cement. However, burning coal releases greenhouse gases and other pollutants, contributing to environmental issues like air pollution and climate change. Petroleum, also known as crude oil, is a liquid fossil fuel found beneath the Earth's surface. It is a complex mixture of hydrocarbons and is refined into various products such as gasoline, diesel, and jet fuel, as well as used in the manufacturing of plastics and chemicals. Despite its versatility, the extensive use of petroleum has raised concerns about its environmental impact, particularly due to oil spills and carbon emissions. As global energy demands continue to rise, finding sustainable and cleaner alternatives to these fossil fuels becomes imperative for a more environmentally conscious and sustainable future. Natural resources. Natural resources are materials and substances that occur naturally in the environment and have inherent value or utility to humans and other living organisms. These resources are essential for the survival and well-being of life on Earth and provide the raw materials necessary for various human activities, economic development, and sustenance of ecosystems. Classification of natural resources. Natural resources can be classified into various categories based on their origin, renewability, and economic use. The main classifications are as follows. 1. Inexhaustible natural resources. 2. Exhaustible natural resources. 1. Inexhaustible natural resources. Inexhaustible natural resources are those resources that are practically limitless and can be used continuously without being depleted. These resources are often renewable and do not deplete even with extensive usage. The primary characteristic of inexhaustible resources is that their availability is not significantly affected by human consumption. Some examples of inexhaustible natural resources include a. Solar energy. Solar energy is derived from the sun's rays and can be harnessed through various technologies like solar panels to produce electricity and heat water. B. Wind energy. Wind energy is generated by the movement of air masses and can be converted into electricity using wind turbines. C. Geothermal energy. Geothermal energy is obtained from the Earth's internal heat, and it can be used for electricity generation and heating purposes. D. Tidal energy. Tidal energy is harnessed from the gravitational pull of the moon and the sun, producing electricity through tidal power plants. E. Hydroelectric energy. Hydroelectric energy is generated by the flow of water in rivers and dams, converted into electricity by hydropower plants. 2. Exhaustible natural resources. Exhaustible natural resources are those resources that exist in finite quantities and can be depleted or exhausted over time due to human consumption or natural processes. Once these resources are consumed, they cannot be easily replaced within a short period. Some examples of exhaustible natural resources include a. Fossil fuels. Fossil fuels like coal, petroleum, crude oil, and natural gas are formed over millions of years from ancient organic matter. They are extensively used for energy production, transportation, and industrial processes. However, their extraction and combustion contribute to environmental issues like air pollution and climate change. B. Minerals. Various minerals like iron ore, copper, aluminum, and precious metals are extracted for industrial purposes and are finite in quantity. C. Groundwater. Groundwater, a crucial freshwater resource, can be depleted if withdrawn at a rate faster than its natural replenishment. D. Forests. Forests are considered exhaustible resources if not managed sustainably. Deforestation and overexploitation of forests can lead to their depletion and loss of biodiversity. Fisheries. Fish and marine resources are exhaustible due to overfishing and inadequate management practices, which can lead to the decline of fish populations and disruption of aquatic ecosystems. Managing exhaustible resources responsibly and finding alternatives to reduce dependence on them is essential to ensure a sustainable and balanced use of natural resources for the benefit of current and future generations. Coal. Coal is a fossil fuel formed from the remains of ancient plants that lived millions of years ago. It is a black or brownish-black combustible rock found in underground seams or open-pit mines. Coal is primarily used for electricity generation and as a fuel in various industries, including steel and cement production. However, burning coal releases greenhouse gases and pollutants, contributing to environmental concerns such as air pollution and climate change. Efforts to transition to cleaner energy sources have led to a decline in coal's usage in some regions, but it remains an essential energy resource in many parts of the world. Story of coal. Ancient use. The history of coal dates back to ancient times when early civilizations, such as the Chinese and Greeks, used coal for heating and metalworking around 3000 BCE. It was primarily surface mined until deeper deposits were discovered. Industrial Revolution. The use of coal significantly expanded during the Industrial Revolution in the late 18th and early 19th centuries. With the invention of steam engines, coal became a crucial source of energy for factories, railways, and ships, driving the rapid industrialization of Europe and North America. Expansion in the 19th century. During the 19th century, coal mining and consumption continued to grow worldwide, especially in the United States and the United Kingdom. The development of coal mines and transportation networks, such as canals and railways, facilitated the widespread use of coal as the primary energy source. Emergence of coal companies. As the demand for coal increased, specialized coal companies emerged to meet the growing needs of industries and urban areas. These companies played a pivotal role in the mining, distribution, and sale of coal. Labor and social issues. The coal industry's expansion led to significant social and labor issues, including harsh working conditions, child labor, and labor disputes. Miners organized labor unions to advocate for better rights and working conditions. Environmental impact. As coal consumption escalated, concerns about its environmental impact began to surface. The burning of coal releases pollutants, including sulfur dioxide and particulate matter, leading to air pollution and acid rain. Transition to alternative energy. In the late 19th and 20th centuries, the discovery of oil and natural gas gradually reduced the significance of coal as the primary energy source. The development of electricity and advancements in other energy sources led to a diversification of energy supplies. Modern challenges and regulations. Despite its decline in certain regions, coal remains a vital energy resource in several countries, particularly in Asia. The environmental impact of coal burning, along with efforts to combat climate change, led to the implementation of regulations to reduce emissions and promote cleaner energy alternatives. Renewable energy shift. In the 21st century, the focus on renewable energy sources like solar, wind, and hydroelectric power gained momentum, encouraging a transition away from coal to mitigate its environmental impact and reduce carbon emissions. Coal's legacy. Despite the decline in some regions, coal's historical significance in driving industrialization and urban development cannot be underestimated. However, the global shift towards cleaner energy sources continues as societies seek sustainable and environmentally friendly alternatives for the future. Coke. Coke is a solid carbon-rich material obtained from heating coal in the absence of air. It is a byproduct of coal gasification or coke production processes. The primary use of coke is as a fuel and reducing agent in the production of iron and steel in blast furnaces. It has a high carbon content and burns at a high temperature, making it an essential component in the steelmaking industry. Coal tar. Coal tar is a thick, black, sticky liquid produced during the destructive distillation of coal. It is a byproduct of the coking process or the carbonization of coal. Coal tar contains various organic compounds, including aromatic hydrocarbons and phenols. It has been traditionally used for various purposes, such as in the manufacture of roofing materials, pavement sealants, and as a base for medicinal ointments. However, due to its toxic and carcinogenic properties, its use has become more limited over time. Coal gas. Coal gas, also known as coal gasification gas or town gas, is a flammable gas produced by the incomplete combustion of coal or the thermal decomposition of coal in the presence of air or steam. The gas mainly consists of hydrogen, methane, carbon monoxide, and small amounts of other hydrocarbons. In the past, coal gas was widely used for street lighting and residential heating before the widespread adoption of natural gas. Today, coal gasification is used to produce synthetic natural gas and chemicals through the gasification of coal and other feedstocks. It is also used in some industrial processes and power generation systems. Petroleum. Petroleum, also known as crude oil, is a naturally occurring liquid fossil fuel found beneath the Earth's surface. It is composed of hydrocarbons, which are organic compounds primarily made up of hydrogen and carbon atoms. Petroleum is formed over millions of years from the remains of ancient marine organisms, subjected to heat and pressure in sedimentary rocks. Refining of petroleum. The refining of petroleum, also known as oil refining or petroleum refining, is the process of converting crude oil into various useful products with different boiling points. This refining process is crucial to obtain a wide range of refined products, including gasoline, diesel, jet fuel, lubricants, and petrochemicals used in various industries. The petroleum refining process involves the following key steps. Distillation. The first step in refining is the distillation of crude oil. The crude oil is heated in a distillation column, and its various components are separated based on their boiling points. As the temperature rises, the lighter hydrocarbons with lower boiling points, such as gasoline and naphtha, rise to the top of the column and are collected. The heavier components, such as diesel, kerosene, and lubricating oils, are collected at different levels in the column. Conversion. In this step, some of the heavier fractions obtained during distillation, such as residual oils, are further processed to convert them into more valuable products. Common conversion processes include cracking, hydrocracking, and coking, which break down large hydrocarbon molecules into smaller, more valuable ones like gasoline and diesel. Treatment. After conversion, various treatment processes are applied to remove impurities and contaminants from the refined products. These treatments may include hydrotreating, desulfurization, and hydrogenation to improve the quality and environmental characteristics of the final products. Blending. Different refined products are blended to meet specific performance and regulatory requirements. For example, gasoline is blended with additives to enhance its octane rating and improve engine performance. Product distribution. Once the refining process is complete, the refined products are transported via pipelines, ships, trains, or trucks to various markets and consumers. The refining of petroleum is a complex and technologically advanced process, and refineries are designed to handle various crude oil types and produce a diverse range of refined products to meet the demands of global energy and industrial needs. Petroleum refinery. A petroleum refinery is an industrial facility where crude oil is processed and transformed into a variety of valuable products. The refining process involves distillation, conversion, treatment, and blending of crude oil to produce fuels like gasoline, diesel, jet fuel, and various petrochemicals used in industries. Refineries play a crucial role in meeting the energy demands of modern society and providing essential products for transportation, heating, and manufacturing. The refining process is complex and requires advanced technologies to separate, upgrade, and purify crude oil into high-quality products that meet specific market requirements. Petroleum refineries are strategically located near oil-producing regions or major transportation routes to efficiently process and distribute the refined products to consumers. Various constituents of petroleum and their uses. Constituents of petroleum. Uses. Petroleum gas in liquid form, LPG. Fuel for home and industry. Petrol. Motor fuel, aviation fuel, solvent for dry cleaning. Kerosene, fuel for stoves, lamps and jet aircrafts. Diesel, fuel for heavy motor vehicles, electric generators. Lubricating oil, lubrication. Paraffin wax, ointments, candles, Vaseline. Bitumen, paints, road surfacing. Natural gas. Natural gas is a fossil fuel composed primarily of methane, CH4, with small amounts of other hydrocarbons, such as ethane, propane, and butane. It is formed alongside crude oil during the decomposition of organic matter over millions of years. Natural gas is often found in underground rock formations or associated with oil deposits. It is a versatile energy resource used for electricity generation, heating, cooking, and as a fuel for vehicles. Some natural resources are limited. While there are abundant natural resources on Earth, not all resources are unlimited. Some resources are considered limited or exhaustible, meaning they exist in finite quantities and can be depleted over time due to human consumption or natural processes. Fossil fuels like coal, petroleum, and natural gas are examples of limited resources. They took millions of years to form, and their extraction and use at a rapid rate can lead to their eventual depletion. Minerals, such as rare earth elements and some metals like copper and zinc, are also considered limited resources. Although they exist in the Earth's crust, their concentrations are not evenly distributed, making their extraction and availability subject to geological factors and economic viability. In contrast, renewable resources like solar energy, wind energy, and biomass are considered inexhaustible or renewable because they are naturally replenished at a rate equal to or faster than human consumption. These resources have the potential to provide sustainable energy solutions and reduce the pressure on limited resources. Managing limited resources responsibly, promoting conservation, and developing alternative, sustainable energy sources are crucial steps towards ensuring a more sustainable and balanced use of Earth's natural resources for the benefit of current and future generations. Thank you for watching. Please like, share and subscribe.